Simplifying exponents. When multiplying like bases, we can add the exponents a plus b. When dividing like bases, we can subtract the exponents a minus b. Having a power raised to a power, we can multiply exponents a times b. If you have a negative exponent, we can take the reciprocal of the term and make the exponent positive. And last four definitions. If you have two terms inside the parentheses, similar to distributive property, we can give each term the exponent. If you have a fraction inside the parentheses, we can give each number of the fraction, numerator and denominator, the same exponent. If you have a fraction to a negative power, we can first take the reciprocal of that fraction, and then with the power outside, we can give to both numerator and denominator. And last definition, any number, any term to the zero power is equal to 1. Title of the first section today is Simplify Exponents. First problem, the first parentheses, 1/3, a to the 8th power, and b to the 2nd power, times a second parentheses, 2, a to the 2nd power, and b to the 2nd power. Simplifying, we can combine both of these terms together. Looking first at the coefficients, we have 1/3 and 2. We can multiply coefficients or multiply the numbers. 1/3 times 2. If you want to, you can make the 2 a fraction, 2/1, multiplying the denominator and the numerator, we'll have 2/3. Combining the a exponents, we have a to the 8th times a to the 2nd. When we're multiplying like exponents or like terms, the exponents we can add together. A to the 8th times a to the 2nd would be a to the 10th power. And b to the 2nd power times b to the 2nd power. Again, we can add exponents when we have a like base. That would be b to the 4th power. So the answer to the first question would be 2/3, a to the 10th, b to the 4th. Second question, and last question for the section. -12, m to the 4th power, and n to the 8th power, times, in parentheses, m to the 3rd power, times n to the 2nd power, all divided by 36, m to the 3rd power, times n. Simplifying this expression, we can first combine like terms on the numerator, leaving the coefficient -12 for right now. We have m to the 4th times m to the 3rd. Again, like bases, we can add the exponents, which will give us m to the 7th, and n to the 8th times n squared. Adding the exponents again, we'll have n to the 10th power. All divided by, leaving the denominator the same, 36, m to the 3rd power times n. Simplifying from here, we can reduce fractions. We have -12 over 36. Reducing fractions, we can divide each of these by 12. So I'll have -1 in the numerator and 3 in the denominator. Dividing fractions, if we have the same base, both m's, looking back at the formulas, we can subtract exponents. 7 minus 3 will give us m to the 4th power. And subtracting the n exponents, n to the 10th divided by n, or we can make it n to the 1st power. 10 minus 1 will give us n to the 9th. So our final answer, -1, m to the 4th, n to the 9th, over 3. Title of the last section today is Simplify more exponents. In this section, we'll continue to simplify exponents using the exponent properties. First question, 30, a to the negative 2 power, b to the negative 6 power, all divided by 60, a to the negative 6 power, and b to the negative 8 power. Simplifying exponents. One of the first steps we can do to get rid of negative exponents is to take the reciprocal of each one. The coefficients 30 and 60 do not have negative exponents, so 30 would remain the same and 60 would remain the same. If we have a to the power of negative 2, if it's a negative 2 in the numerator, we can rewrite that a to the positive 2 in the denominator. And likewise, if we have a to the negative 6 in the denominator, we can rewrite that in the numerator, changing the exponent to a positive 6. Also with the b's, b to the negative 6, we can write in the denominator as b to the positive 6, and b to the negative 8, we can write in the numerator as b to the positive 8. Simplifying from here, the coefficients 30 and 60, we can reduce or divide those. Dividing each one by 30, we'll be left with 1 over 2. Exponents again, when we divide the like terms, the exponents we can subtract. 6 minus 2 would be a to the 4th. And subtracting the b exponents, 8 minus 6 would be b to the 2nd power. So our final answer would be a to the 4th, b squared, divided by 2. Second question, and last question for the section. Inside parentheses, we have 4x to the negative 3rd power times y to the 2nd power divided by x, y to the negative 5th power. And outside parentheses, raised to the power of negative 2. One way to start this question, the exponent outside negative 2 goes to each number and each term inside the parentheses. We have 4 to the negative 2 power, which would be 4 to the negative 2. Taking the negative 2 to the x power, having a power to a power, looking back at our rules, we'll multiply exponents. Negative 3 times negative 2, that would be x to the positive 6. And continuing the numerator, we'll have the exponent of 2 raised to the power of negative 2, or 2 times negative 2 would be y to the negative 4. For the denominator, each question will get a power of negative 2. If there's no exponent on the x, we can put a 1. So we'll have 1 times negative 2, or we'll have x to the negative 2 power. And for the y term, negative 5 times negative 2 would be y to the positive 10th power. Simplifying from here, any negative exponents, we can change those around by taking the reciprocal or switching the spots on the fraction. If we have 4 to the negative 2 in the numerator, we can rewrite that as 4 to the positive 2 in the denominator. X to the 6 would stay the same since it's positive. Y to the negative 4, we can move that to the denominator and change it y to the positive 4. X to the negative 2 in the denominator, we can switch that to the numerator and make it x to the positive 2. And y to the positive 10 would stay the same in the denominator. And last step, combining like terms. X to the 6 times x squared. If we have the same base, we can add the exponents, which would be x to the 8th over 4 squared would be 4 times 4, 16. And y to the 4th times y to the 10th. The same base again, we can add the exponents, which would be y to the 14th. So our final answer, x to the 8th over 16 times y to the 14th. Polynomials, we have two definitions for polynomials. The first one is a polynomial you can't divide by a variable or take a square root of a variable. If you divide by a variable or have a square root, then it is not a polynomial. For the degree of a polynomial, degree is the highest exponent or exponent total of a term. If you have a single variable, we'll take the highest exponent. If we have more than one variable, we'll take the exponent total, or the sum of the exponents of each term, and the highest exponent total will be the degree. Title of the first section is Degree of a Polynomial. First polynomial we'll look at is 3x squared plus 2x minus 1. Again, the degree of the polynomial is the highest exponent. Highest exponent in this case would be 2, so the degree would be 2. Second question, x cubed times y squared plus x divided by 2 minus y. Looking for the degree again. When you have two variables, we can add the exponents together, which would make this an exponent total of 5. The other two terms have an exponent of 1, so the degree for this polynomial would be the exponent total would be 5. And last question for the section, x squared minus 1 over x. Looking at the highest exponent would be 2, but the second term we're dividing by x or dividing by a variable. Anytime you divide by a variable, this expression is not a polynomial. If it is not a polynomial, then there is no degree. The expression is not a polynomial. Title of the next section is Simplifying Polynomials. In this section, we'll simplify polynomials by combining like terms. First problem. First set of parentheses is 3x squared minus x plus 2 plus a second parentheses x squared plus 4x minus 9. To simplify polynomials, we can combine like terms. Like terms would be the same variable and same exponent. Combining the x squareds together, we'll have 3x squared plus another x squared, which would be 4x squared. Combining the x's, negative x plus 4x would be plus 3x. Negative 1 plus 4 would be 3. And 2 plus a negative 9, or 2 minus 9, would be negative 7. So our final answer, 4x squared plus 3x minus 7. Second question and last question for the section. First parentheses, 10x squared minus 3xy plus 4y squared. Minus a second parentheses, 3x squared plus 5xy. Simplifying polynomials, we can subtract these two terms together. Again, combining like terms. The x squared we can combine with the other x squared. 10x squared minus 3x squared would be 7x squared. The xy we can combine with the other xy. Negative 3xy minus a positive 5xy will be negative 3 minus 5, which will be negative 8xy. And last term we haven't used 4y squared. There's no other 4y squareds to combine with it, so it will stay the same, plus 4y squared. So our final answer is 7x squared minus 8xy plus 4y squared. Title of the last section today is More Simplifying Polynomials. First question is 4a times, in parentheses, 3a squared plus b. Simplifying this expression, the 4a, we can use distributive property to multiply inside the parentheses. Multiplying 4a times 3a squared, the coefficients we can multiply. 4 times 3 would be 12. And a times a squared, if you want to, you can put a 1 for the exponent. Multiplying like terms, we'll add the exponents. So a times a squared would be a to the third. Plus 4a times b. Since they're different letters or different variables, you can write them side by side, which would be 4ab. So your final answer, 12a cubed plus 4ab. Second question, inside parentheses x minus 3y to the second power. Simplifying this expression, since we have two terms on the inside, separated by a plus or minus sign, the squared means we'll have the same parentheses twice. So x minus 3y times x minus 3y. We have two parentheses or two binomials being multiplied. To simplify this, we can multiply using FOIL. Multiplying the first terms, x times x would be x squared. Multiplying the last terms, x times a minus 3y would be minus 3. X times y would be xy. Multiplying the inside terms, negative 3y times x would be negative 3. And we can put x first times y. And multiplying the last two terms, negative 3 times negative 3 would be positive 9. And y times y would be y squared. Simplifying, we can combine like terms. Minus 3xy minus another 3xy. Negative 3 minus 3 would be negative 6. And the xy would stay the same. Plus 9y squared. So our final answer, x squared minus 6xy plus 9y squared. And the last question for the section. The first parentheses, x squared plus xy plus y squared times a second parentheses x minus y. Multiplying, we have a trinomial with 3 terms times a binomial with 2 terms. Similar to distributive property, we can multiply x times each of the 3 terms inside the parentheses. And after that, we can multiply y times each of the 3 terms. Multiplying x times x squared. Again, you can put an exponent of 1. Multiplying like bases, we'll add the exponents, which would be x to the third power. X times xy. Multiplying 2 x's will be x squared. And putting y after, so x times xy would be x squared y. And multiplying x times y squared would be x y squared. For the second part, we'll multiply negative y times each of the three terms. Negative y times x squared would be minus x squared y. Multiply negative y times xy. We'll have negative x, and y times y will be y squared. And multiplying a negative y times a y squared, we'll have negative y to the third power. Combining like terms, x squared y minus x squared y. Each of these would cancel. And also xy squared minus xy squared. Each of those would cancel. So our two terms left is x cubed minus y cubed. So our final answer would be x cubed minus y cubed. Title of the first section today is dividing by a monomial. In this section, we'll divide by a monomial. Monomial only has one term. First question, 9a cubed b squared minus 18a squared b cubed divided by 3a squared b. To divide by a monomial, which again only has one term, we will take this by monomial and divide it by each number and each term in the numerator. So we'll divide 9a cubed b squared by the monomial, and we'll also divide negative 18a squared b cubed by the monomial. Dividing this out, the first term, we can divide the coefficients, 9 divided by 3, which would be 3. A cubed divided by a squared. If you remember in previous sections, when we divide like bases, we'll subtract the exponents, 3 minus 2, which would be a. And b squared divided by b, subtracting the exponents, if you want to, b can be b to the first, 2 minus 1 would also be 1. So our first term will have 3ab. Bringing down the minus sign for the second term. And again, dividing the second term by the monomial. 18 divided by 3 would be 6. A squared divided by a squared. If you subtract the exponents, you'll get a to the 0 power. A to the 0 power is also 1, or we can leave it off. And b cubed divided by b to the first. Subtracting the exponents, we'll add b squared. So our final answer, 3ab minus 6b squared. Second question and last question for the section. First term in parentheses is 18x squared y plus 27x cubed y squared z, and close parentheses. Outside parentheses, we'll have a second parentheses, which will be 3xy raised to the negative 2 power. Looking at this question, it looks like we're multiplying two parentheses, but if you remember, negative exponents means we'll take the reciprocal of this expression. So what we can do is make the first term a fraction, and instead of multiplying by a term to the negative 2 power, we can rewrite 3x squared, 3xy in the denominator, and changing the negative 2, we can change it to a positive 2 after taking the reciprocal. So instead of 3xy to the negative 2 power being multiplied, we can divide by 3xy squared on the outside. Before we divide by the monomial, we have to simplify this first with the parentheses. If you remember, the square will go to each number and each term on the inside. So simplifying just the denominator, 3 squared would be 9. X will have a exponent of 2. And y will also have a exponent of 2. So instead of dividing by 3xy, we'll be dividing by 9x squared y squared. Simplifying from here, we'll have 18x squared y divided by 9x squared y squared. 18 divided by 9 would be 2. X squared divided by x squared would divide out, or be x to the 0, which would be 1, so we'll keep the 2. And y divided by y squared, we put an exponent on here, y to the first divided by y squared, subtracting 1 minus 2 will give us y to the negative 1 power. Plus the second term, 27 divided by 9 would be 3. X cubed divided by x squared, subtracting the exponents, we'll have x. Y squared divided by y squared would cancel out, and we'll have a single z left over. Simplifying from here, when we have negative exponents, we can rewrite this using a reciprocal. The 2 would stay the same since it does not have a negative exponent, but y to the negative 1 we can put on the denominator, changing to a positive 1, or we can also leave the 1 off. Plus 3xz would stay the same. So our final answer, 2 over y plus 3xz. Title of the last section today is Dividing Using Long Division. In this section, we'll divide polynomials using long division. First question is a question without variables. 101 divided by 3. Taking these two numbers, we can divide them using long division. If you remember, for long division, the number that goes inside is the numerator, which is 101, and the number we're dividing by, or the denominator, goes outside the dividing sign. Dividing from here, 3 doesn't go into 1, but 3 will go into 10. 3 goes into 10 3 times, and then we'll multiply 3 times 3, which would be 9. After we multiply, if you remember, we'll subtract. 10 minus 9 would be 1. And after we divide, we can drop down the next number, which would be 1. 3 into 11 would also go 3 times. And again, multiplying 3 times 3 would be 9. Subtracting, we'll have 2 left over, or a remainder of 2. Instead of putting zeros up here and dropping down more numbers, we can use this 2